The surface of Venus is 465 degrees Celsius right now, not because of a volcanic eruption, not because of a solar event, not because of anything dramatic or unusual. That is simply the average, everyday, unremarkable temperature on the surface of Venus at this exact moment. To put that in terms your kitchen can understand, your oven maxes out at around 260 degrees Celsius. Venus runs nearly twice that. All day, every day, forever. And that is just the opening fact. That is not the worst part. Venus sits roughly 41 million kilometers from Earth at its closest point. In cosmic terms, that is nothing. It is our nearest planetary neighbor. On a map of the solar system, it looks like a short drive. Early astronomers looked at Venus through their telescopes and saw a planet almost identical in size to Earth, shrouded in thick clouds, and they thought, maybe there are oceans under those clouds. Maybe there is jungle. Maybe there is life. For most of human history, Venus was the dream planet, not Mars. It was closer, brighter, and seemed full of mystery. The nickname, Earth's twin, wasn't irony, it was genuine hope. Then we sent probes, and everything changed. The dream of Venus exploration has never fully died. Even today, engineers at NASA and the European Space Agency have drawn up serious mission concepts for landing humans or long-duration robots on the Venusian surface. There is a proposal called Da Vinci, another called Envision. Scientists argue Venus holds crucial data about how rocky planets evolve. And they are right. Understanding Venus could help us understand Earth's future. The scientific motivation is real and urgent. If we could land there, study the rocks, sample the soil, peer beneath those clouds in person, we would rewrite planetary science. The knowledge waiting on that surface is extraordinary. The problem is that nothing built by human hands, and certainly no human body, can survive long enough to collect it. Here is where the temperature story gets genuinely strange. Venus is farther from the Sun than Mercury. Mercury, the innermost planet, bakes in direct solar radiation with almost no atmosphere to speak of. Its dayside reaches around 430 degrees Celsius. That sounds brutal, and it is, but Venus still beats it. A planet farther from the Sun runs hotter than the planet closest to the Sun. That fact alone should stop you cold. The reason is the atmosphere. Venus is wrapped in a carbon dioxide atmosphere nearly 90 times denser than Earth's, laced with clouds of sulfuric acid, and that atmosphere has spent billions of years trapping solar heat with ruthless efficiency. The greenhouse effect on Venus isn't a climate concern, it is a planetary furnace. Heat enters and essentially never leaves. The surface temperature doesn't fluctuate meaningfully between day and night, between equator and poles. It is a global, locked, permanent 465 degrees Celsius, give or take a few degrees depending on elevation. Lead melts at 327 degrees, zinc melts at 419 degrees. On the surface of Venus, both of those metals exist as liquid puddles, tin, bismuth, and a dozen other metals that feel solid and industrial and permanent to us. Liquid on Venus, just sitting there, pooled in the rocks. Now add the pressure. At the surface of Venus, atmospheric pressure reaches approximately 92 bar. 1 bar is roughly the pressure you experience standing at sea level on Earth. 92 bar is the pressure you would feel diving 900 meters beneath the surface of the ocean. Not 90 meters, not 200 meters, 900 meters down, in the crushing dark, where submarines are specifically engineered to survive, and most of them still wouldn't risk it. That pressure doesn't just push on you, it compresses you. It forces itself into every cavity, every lung, every sinus. The atmosphere of Venus is also not merely unbreathable, it is chemically aggressive. Carbon dioxide dominates, yes, but the cloud layers above contain concentrated sulfuric acid droplets capable of dissolving metal. The wind at the surface moves slowly, almost gently, but it doesn't need to be fast when everything it carries is corrosive and the air itself is an industrial acid bath. The human body has exactly 0 biological tools for any of this. We evolved on a planet where the worst natural heat a person typically encounters is around 50 degrees Celsius in extreme desert conditions, and even that is lethal within hours without intervention. At 465 degrees, human tissue doesn't struggle or weaken, it denatures. Proteins, the molecular machinery of every cell in your body, unravel almost instantly above roughly 40 to 45 degrees Celsius internal temperature. Your enzymes stop working, your cell membranes rupture. The chemical reactions that constitute being alive simply cease. Before you registered pain, before your nervous system transmitted a single alarm signal, the biology of your body would have already crossed the threshold of irreversible destruction. The term re is no suit material that currently exists, and none on the drawing board for human use. that could maintain a survivable internal temperature on the Venusian surface for any meaningful duration. The thermal load is simply too enormous. You would need a refrigeration system so powerful, running continuously, drawing energy from a source robust enough to keep operating at 465 degrees, that the engineering problem becomes recursive and unsolvable with known technology. And even if we somehow solved thermal protection, the pressure suit required to keep a human alive at 92 bar would be less of a suit and more of a personal submarine. The thickness and rigidity required to resist that pressure would make movement nearly impossible. You would not be exploring a surface. You would be standing in a bunker you happen to be wearing, and that bunker would need to resist not just crushing pressure, but constant chemical exposure from an atmosphere that dissolves metal over time. The Soviet Venera probes, the most successful Venus landers ever built, were constructed from hardened steel, designed specifically for this environment, and the longest any of them survived on the surface was 127 minutes. 1 hour and 7 minutes. That was Venera 13 in 1982, and it is still the record. Engineered machines built for that specific purpose lasted just over 2 hours. A human being, inside any suit we could realistically conceive of, would not approach that number. The cascading failures don't stop there. Consider the communication problem. A crewed Venus lander would need to maintain contact with an orbiting spacecraft or with Earth. The dense, electrically active atmosphere of Venus degrades radio signals significantly. The sulfuric acid clouds scatter and absorb transmissions. Even our best probe communications from the Venusian surface were intermittent and degraded. For a crew depending on telemetry, navigation data, and emergency guidance from mission control, that communication uncertainty is not an inconvenience. It is a potential death sentence in any scenario where something goes wrong and instructions need to be transmitted quickly. And on Venus, things going wrong is not a contingency. It is a baseline assumption. Every material degrades faster, every mechanical seal faces pressures and temperatures it was never optimized for, every redundant system faces the same environment as the primary system. When one thing fails, and something always fails, the backup is already compromised by the same conditions that broke the first. Venus doesn't kill you dramatically. It kills you completely and immediately and in every way at once. The heat overwhelms your biology before you can register it. The pressure crushes every air pocket and cavity in your body. The atmosphere corrodes anything designed to protect you. And the environment is so hostile that the machines we've actually built and launched there, purpose-designed Soviet steel probes, lasted barely long enough to send back a few photographs. This is not a planet that humanity failed to conquer through lack of trying or lack of imagination. This is a planet where the fundamental conditions exceed what carbon-based life and current human engineering can endure simultaneously, with no single fix that resolves all of it. Distance is an obstacle you might engineer around. Radiation is an obstacle you might shield against. But Venus presents a complete environmental package: heat, pressure, chemistry, and corrosion that compounds rather than stacks, and where solving one problem does nothing to reduce the lethality of the others. There is something quietly strange about the fact that Venus is visible to the naked eye. On certain evenings, it is the brightest object in the sky after the sun and moon. People have made wishes on it, mistaking it for a star. Poets have written about it. Lovers have pointed to it. And underneath that brilliant white light is the most hostile surface in the solar system. A place where lead runs like water, and the air weighs as much as the deep ocean, and every known biological process, every material ambition we have, stops. We will study Venus from orbit. We will send more probes, more carefully designed, more resilient. We will learn from it and understand our own planet better because of it. But the surface of Venus will remain, for the foreseeable future of human civilization, completely and permanently beyond our reach. Not as a failure of will, as a statement of physics. We are a species that looked at the night sky and refused to accept that the lights were just lights. That refusal produced telescopes and mathematics and eventually spacecraft. The fact that we know exactly how hot Venus is, exactly how crushing its atmosphere is, exactly why it became what it is, that knowledge came from us, from probes we built and launched and guided across millions of kilometers. We may never stand on that surface, but we already know it better than any civilization in human history. And in the end, that understanding is its own kind of extraordinary. If you found this fascinating, let me know. I'll see you in the next one.